All right, now we're moving on to voltage, which is a little bit more difficult to wrap your head around, but we'll get started. So we'll start with the idea of potential energy. So this isn't actually related to electricity, but let's go. Potential energy. So say you are standing next to a tennis ball on the ground. And say you lift up that tennis ball. So the idea of gravitational potential energy says that this ball is now at a higher potential energy. So this ball had zero energy. Joules is the energy term, like meters is for distance. So 0 joules, and then you lift it up, and now you've given it potential energy. So you've put it up, takes about a joule of energy to lift it. You're actually transferring that from your body as a side. So, I had about 2000 joules for breakfast, so I'm using one of those joules to pick this up. And so now that's at 1 joule. So if I let go of that ball now, all the energy that I spent bringing it back up is going to get released, and the ball is going to bounce up and down and start moving quickly and stuff. So I'm changing the gravitational potential energy that I took to lift it up back into, I think kinetic energy is the term, just moving energy. Okay, so it's at 1 joule. So, and now imagine we have a bowling ball like that. And it's a fair bit bigger. So it's about 10 times heavier. So if you lift that up the same distance, now if you can guess how much energy it took to lift that up, if you said 10 joules, you'd be correct. So it took 10 joules to lift that up. So now let's get that tennis ball again, and we'll lift it twice as high. And guess how many joules of potential energy? If you said 2 joules, you were right. And 20 joules if you lift that twice as high. So we can see that the parts that create the formula for potential energy, it depends on your height, and it depends on how heavy it is. So height and mass. Now let's go back to charge. So say you have one charge here and one charge right on top of it there. Actually, you know what? We'll make this positive and negative so it's easier to. So minus and plus. So say you remove that charge a little bit up, one distance, 1 meter, whatever you want, 1 kilometer, doesn't matter. So you lift it up one little bit, and so now it's at a potential energy. So if I let this charge go, it's just gonna fling back to that because it attracts. It's like the magnets in the charge. See the charge video if you don't get that. So it's just gonna fling back. So right now, we're holding it at a potential energy. We'll say it's 1 joule. Now say the charge we're using is twice as big. It's going to take twice as much energy to lift it up, right? Like in here. So this potential energy would be at 2 joules. Now say, like we did here, that we lift it twice as high. Just say that, run out of space. So twice as high. So now it's gonna be at, if we're talking about the double size one, it'll be twice as high and twice as heavy. So it'll be 2 times 2 equals 4 joules. So what we can see here is it depends, the potential energy depends on both the charge size. Remember, we doubled this, so it was twice as much energy going into it compared to this. So it depends on charge. And it also depends on height. And we can see here, so it's actually timesing because you got 2 times as much and then 2 times as much again. So it's charge times height. Now, when we're talking about potential energy, it's kind of annoying because we have to take charge into account. And charge is really difficult to calculate. Engineers don't really like it. So we much prefer to just talk about the height. If we want, we can just, so let's just get it focused on height. So potential energy over charge equals height. So all of this is to explain what that height is really important. And the height is also called voltage when we're talking about electrical things. So it's analogous to height. When you think of voltage, I want you to think of height. But it definitely doesn't mean potential energy. That's one thing I got messed up with a lot of time. So if you have a ball up here, these ones are at the same height. So they'd be at 1 meter height, but they have different energy because the mass is bigger, because the mass of the ball is bigger or smaller. Same with the voltage. So these two, so let's go. These two are at the same height, so the same voltage, but there's different energy attributed to both. This one has twice as much energy because it's twice as big. But regardless, what we like to do here is potential energy over charge. And what happens here is once you divide this out, it actually just becomes the potential. So you might hear it be called the potential as well, the voltage potential. And we use this all the time. So that's how we get the term voltage, which you're going to use a lot. It's in pretty much every single electrical circuit and analysis. And yeah, that's also why it's called potential. And you can see, if you want to get the units, it's potential energy divided by charge. So joules, that's our potential energy. And then charge, which is in coulombs, joules per coulombs. And that equals 1 volt.